All right, let's talk about something every data scientist runs into. You build an amazing model, it runs like a dream on your machine, but then what? Today, we're going to tackle exactly that. We're turning those brilliant, but let's be honest, sometimes messy Python scripts into slick professional command line tools. This is a key skill if you're moving into MLOps, so let's jump right in.
So, here's our game plan. First, we'll dig into why just having a script isn't enough. Then, I'll introduce you to the solution, your code's new front door, the package entry point. We'll get our hands dirty and actually build one step by step. After that, we'll see how these things power real-world MLOps pipelines, and we'll wrap up with some pro tips to make sure your tools are totally production ready.
Okay, first up, the problem. And this is a pain point I know you felt. You spend weeks, maybe months, building this incredible model. It's a work of art. But then you have to hand it off, and suddenly it's a mess. Trying to explain to someone else how to run it, it's a nightmare. Your amazing work, your models, they really do deserve better than that.
So I want you to ask yourself this. Honestly, is your code truly reusable? Like, if you gave it to a teammate, or even worse, an automated pipeline, could they run it without you having to explain, oh, you need to be in this specific directory, or make sure you run it with this exact path? If you're hesitating at all, you are absolutely in the right place.
Let's really break this down. With a standalone script, you're stuck with this long, ugly command that depends on the exact path to the file. If anything moves, it breaks. And dependencies? Who knows? It's basically a black box. But with a package entry point, it's just a clean, simple command, like my command. That's it. It's installed right into the environment, it brings its dependencies with it, and anyone can find it and use it. It's the difference between a fragile science experiment and a robust professional tool.
Okay, so we've seen the problem, right? The clunky, fragile script. Now let's talk about the elegant solution. It's time to build a proper front door for your code.
So what is a package entry point? Well, think of it literally as the front door to your code. It's the one official, public way to get in. It provides a stable, clean interface so that other people, and more importantly, other programs, can use your application without needing a map of all the messy hallways and back rooms inside. They just knock on the front door.
So why bother with this? Well, you get 3 huge wins. First, execution becomes dead simple. No more typing out Python path / to some crazy long script.py. Second, it just makes your tool way more usable for everyone. But the third reason, this is the real kicker for MLOps. It enables automation. Things like CI/CD pipelines or orchestrators like Airflow, they live on these simple, reliable commands. They're the Lego bricks for building powerful automated workflows.
Okay, time to get our hands dirty. Now, I know this might sound a little intimidating, but I promise you, creating an entry point is surprisingly simple. It's really just a 3-step blueprint to build a professional command line interface. Let's walk through it.
Here it is, the whole process in a nutshell. 1, you set up a parser to handle your command line inputs. 2, you wrap your main logic in a neat little function. And 3, you make one simple declaration in your project's config file. That's literally it. Let's break down each step.
First up, the command line parser. This is all about making your tool flexible. You use a library, probably Python's built-in argparse, to define the arguments your tool can take. You know, things like an input file path, or maybe a flag to turn on verbose logging, or a number for the learning rate. This is what lets other people actually configure and use your tool from the command line.
Step 2, structure your code. You're going to take all that core logic and put it inside a single main function. But here's the absolutely critical part, so listen up. Your function has to return an integer. A return 0 means, hooray, everything worked. A return 1 or any non-zero number means, Houston, we have a problem. This isn't just a suggestion. It's the universal language that automation tools understand.
And for our final trick, step 3. This is where the magic happens. You open up your project.toml file, and under the project.script section, you add one simple line. It's basically command name equals path.to.yourmodule.main function. So you're just telling it what you want the command to be called and where to find that main function we just made. That's it. When you or anyone else installs your package, the tooling takes care of the rest, and poof, That command is now available in the terminal.
Okay, so now you know how to build one. But let's look at the bigger picture. Let's see why this one little trick is so incredibly fundamental to modern MLOps. Because this isn't just about making things look nice, it's about building systems that can actually scale.
This quote really nails it. Decouples the orchestration from the implementation. What does that actually mean? It means the thing running the job doesn't need to know how the job works. Think about it. Your Airflow DAG doesn't care if your training script is written in TensorFlow or PyTorch. It doesn't care about the nitty-gritty details. All it needs to know is the command to run and whether it succeeded or failed. That separation is everything.
Let's make this super concrete. Imagine you have a workflow. Your orchestrator, let's say it's Airflow, wakes up and says, okay, it's time to run a training job. It then tells your execution engine, maybe Databricks, to get to work. But what does it tell Databricks? It doesn't send the Python code. It sends one simple command, bikes run training. That's it. Your entry point is the clean, simple contract that lets these powerful systems talk to each other without getting bogged down in the details.
All right, we're in the home stretch. You know how to build an entry point? Now let's talk about how to build a great one. These are the best practices that will take your tool from "it works" to "it's truly production ready."
Okay, 3 key principles here. First, separate your configs. Put static stuff that rarely changes, like model architecture, in a config file. Use command line arguments for the dynamic stuff that changes with every run, like the date. Second, stop using print for logging. Use a proper logging library that produces structured, machine-readable output. Your future self will thank you. And third, the single responsibility principle. Don't build one giant do-everything command. Make small focus tools, one for training, one for predicting, one for data validation. Keep them clean.
I'm going to say this again because it is that important for automation. A machine can't read the sentence "script finished successfully." It's just a string of characters. It has no idea if that means good or bad. But when it sees an exit code of 0, it knows. That's a universal signal for success. An exit code of 1, universal signal for failure. If you want to build reliable, automated systems, this is not optional. It's the law.
And that brings us to the big question for you. Think about the projects you're working on right now. What's the one script? Maybe it's for data cleaning. Maybe it's for running predictions. What's the first one you can transform into a proper, professional command line tool using what you've learned today? Find it and give it a shot. That's all for this explainer. Thanks for tuning in. Now go build something awesome.